So before going to the welding process, we have to, because welding process, all of you have may know what is welding process. It's a joining of materials that we known as a that we call as a welding process. But we'll see what is actually the welding process and what different kinds of types of welding processes are available. So before that, so we have to know some brief about the materials that have been used in engineering work. So that will be classified into two ways. One is metallic materials, one is non-metallic materials. So among the metallic materials, there will be two categories. One is ferrous, one is non-ferrous. So ferrous materials, you all know that which have the iron as their main constituent, such as pig iron, cast iron, wrought iron, steels. Those are the ferrous material. Similarly, we have non-ferrous material like copper, aluminum, brass, bronze, tin, silver, zinc. Those are the example of non-ferrous. So, engineering materials are classified into metallic materials and non-metallic materials. So, in metallic materials, there will be two more classification. One is ferrous materials, another is non-ferrous materials. Then among the in case of non-metallic materials, we have two other classifications like organic and inorganic. In case of organic, we have got plastics, wood, paper, rubber, leather, petroleum, and inorganic minerals, cement, glass, ceramics, graphite. So these are the classification of materials which is used in day-to-day engineering life. Okay, so next I will go for the welding process. So you can see, so first is why the joining process. So before going to the welding process, I will like to take a point of joining, because welding is nothing but a joining process. So what kind of joining process are available? So joining process, if you can see the definition here, so joining is an all-inclusive term all-inclusive term covering processes such as welding, brazing, soldering, adhesive bonding, and mechanical fastening. So all those things have cover fall under the category of joining. So joining includes welding, brazing, and adhesive bonding. You have Fevicol, you have heart, that is adhesive bonding. Then mechanical fastening, you have bolt, that you have seen, that will mechanical fastening without doing any joining, like it's a joining using some other by pressure, with the help of pressure by hammering it. Then if you can see the application of the welding processes, joining processes in the car, while manufacturing in automobile industry, there is all the parts of your car has been joined together to make it a, to make this a final product as your car. So much of joining processes are involved here. You can see here bonding of windshield to car body, that is one kind of joining. Then we have the fasteners, that we can call as a mechanical fastening. Then bolted engine assembly, that will call as a that will call similarly, that will be fall under the mechanical fastening. Then we do the soldering, then we'll call do the brazing. So you see, so many joining processes are involved while manufacturing a car. So now you have seen adhesively bonded fabric. So whatever the even cushions, whatever the that provided, that are done by using adhesive bonding. Then we have seen the welding processes. So spot welding processes. Then mechanical fast. This is a welding processes. Then this is the welded pipes for exhaust system. So many welding processes are involved in simple while making a car. You can see. So joining process is so much essential. So now we'll tell you the. So what I have understood, first previously we have seen that what type of materials are available in whatever the engineering materials are available. Among that we have got, one is metallic, one is non-metallic. So among the classification of metallic is ferrous, non-ferrous. Then classification of non-metallic will be organic and inorganic. So now we'll see the definition of welding. So how it is differ from the brazing or soldering, that we'll see. So up to this, any doubt, any confusion? Is there any confusion up to this? Okay. If there is no confusion, I will proceed. Okay. So we'll now see the welding processes. So in your course, only arc welding and gas welding is there. Okay. Now we'll see what type of welding processes are there. So welding differs from soldering and brazing in that. So we'll see. Now you just remember this term only. One is welding and it is differ from, I'll highlighted it. One is welding, one is welding and it's differ from soldering and brazing in that in welding processes normally no alloy is used to join the metals together. Here, no externally the materials have not been pulled. While soldering, the solder materials have been used. While brazing, the brazing materials have been used. Externally, we have put some materials to join the base metal. So join the base material. So if you can see, so what you have seen here, there is a these are types of welding. Oh, I will go into that, but just know what thing you have to know that you see the fixture here. So what is that? This is the base material. So now it is base material is the material metal they have taking some metal. Okay, this is the base material. We have to join this base material using this welding. So this welding is done by, I think it is done by arc welding or that by any fusion welding. So this is done by some fusion welding processes. So while fusion welding, this welding material, this is comes how this material has come. This is material has come just by melting this base material. After melting of this base material, it forms like this. So this kind of it is a that kind of it is a welding where the you have to put heat to melt the base material, and after that what you have to do, either you have to bring to the plastic state or to the molten state. So I think you have whoever present in the last class, I have mentioned about the plasticity and elasticity. Have you remembered? So how can you, like, if the material, if you can remember properly what I'm saying, that if the material is elastic, what will happen? If the material, listen to my thing, listen to it properly. If the material is elastic, then the what will happen if the force, if you remove the force, because now, or remove the pressure, force or pressure, you can just take it, because the pressure things will be here. In case of welding process, the pressure, what are the things are there in the welding processes? One is heating. Heating is heating is the only thing which is constant with the welding processes. So you have to put heat to join the material, that is fixed. Okay, either you do that joining either by pressure or by molting the metal. Depending on that will have different classifications. Are you getting it? So we have to put heat to join this base material. This is the one part of this base material, and this is the one, this is fallen apart, and we have to join that material. And we can do it by putting heat and bring the and molten this this base material, or by we putting it and bring the this material to the plastic state, and after that we have to put pressure and join this material. So because if the material is elastic, we cannot join it, because after the putting the pressure, what will happen? It again regains its original shape and size. But if the material is plastic, if the materials that plastic, you have the I've shown the curve. If the material the who uh, have already gone through the elastic state and comes falls into the plastic state. So if you put enough heat and bring the material into the plastic state, then we can join the material by using some pressure. So from that, we'll come to know about different kind of welding processes. So at these cases, in the welding process, no external material has been used to join the material, so join the base material, no external. But in case of soldering or brazing, we have those soldering, that solder material is going into the base material to join that. And you have to replace it, the soldering material you have to replace by time, because that is going to be deposited in the base material to join the material. Similar case to the bridging. But welding, there is no other joining material, it is only the whatever the material we want to join, that is only joined by either it is being to the plastic state or by mold, either by melting it. Okay. So here in the next line, it is the line is given. The welding the materials being joined are locally melted. When solidified, produce a solid mass. So after melting, if you give time to solidify, then it will join the material, or giving a joint strength to strong as metal to join. So bring the plastic state, then we put pressure to make the joint. But you should not be confused with the filler rod with the soldering. There is maybe a filler rod is sometimes used in case of welding, because you should not be confused with this term. This this filler rod term with the brazing, soldering and brazing. Actually, this is the it is the artificial one. It is not a actual process of welding. It is an auxiliary kind of thing. Like if there is what will happen if the filler rod is used, you can see for to cover the material loss during the welding. If there is some material loss during the welding, to cover that thing, we have used filler rod. It is not a essential one. It is not a necessary process. It is the auxiliary process to if there is some material process. If eventually there is some material loss, then we are going to use the filler rod to fill the gaps between the joint surface and to produce a fillet. And also there is some flux is required. So we see different kind of material has been used to remove the recur to. So whatever the oxide formation has been found, we can case of case welding processes to remove those oxide film. We sometimes we have used this flux. Okay. So the definition of weld is a union between the pieces of metal at faces, rendered plastic or liquid, or by heat, or by pressure, or by both. Thus, I'm. What have you understood by this? I'm zoom it out. So you can write in the chat box. I'll just ask a question. A union body, okay? A union between the pieces of metal at faces render plastic. When the plastic is used, uh, does it require pressure or not? Your answer, uh, yes or no. Whether it will require plastic, in case of bring the plasticity, if you want to join the material using by bring the material to the plasticity, whether the pressure is required or not. What is your answer? Yes or no? Simply write in the chat box. No. Okay. What about others? Write it in the chat box. Yes or no? Anyone? Or you can just unmute yourself, and if you have not understood my question, then you unmute yourself and ask me. Anyone? Anyone? Yes, yes, sir. Okay. What about other? Monojit only you have replied. Pressure is required, I think. Okay. For plasticity. Okay. What about other? For welding process to join the material, I'm writing it. I write the question in the sandbox. To join the material by bringing the base material. Base material means the material which I want to join. The base material to the plastic state, whether pressure is required or not. Pressure is required or not. Yes or no? Oh, welding process to join the material, that is the base material, by bringing the base material to the plastic state, whether the pressure, spilling of pressure is wrong, okay, no problem. Bring, uh, whether pressure is required or not. Yes or no? Yes or no? Write it. Monojit has given and he said that pressure is required. What about others? Nothing. If you said wrong, also there is no problem. You just write it down. There is no problem of whether you no, sir. Okay, okay, okay. Others. Okay, I think no, sir. Okay, okay. So then I will put a next question. Okay, okay. Now you say that no. Then I will put a next question. If it is clear, then there is no problem. For welding process to join the material by bringing the base material to the molten state. Now I have bring the material plastic instead of plastic. I just change the question to the molten state, whether pressure required or not. Now what will be the answer? Jyotirma, you have given the answer for the this question or last question? This question. It, it is required for molten. Yes. Okay. Whatever. Others. Okay. Okay. I have got it. That. And what about Monojit? Because you have only the like you have said different from the others. What about Monojit? What about the new question? What new answer for the new question, Monojit? Whether it is required or not? Because you said that in the plastic state pressure is required. And what is your answer for molten state? Whether pressure is required or not?
Uh, I'm not sure. Here, heat is required. It is, but
Heat
I
is
don't know.
required. Yeah, heat is required for the both. In welding process, heat is the only the thing which
Yes,
will be there. Other pressure will be there or not, that is a issue only. On base
that I'm
of
not
that,
sure, sir.
yeah. So I am now telling it. Okay. So first question is the to bring the material to the plastic state. So in the plastic state, pressure is required because we have to after the bring the plastic state, we have to join it by pressurizing it. Then we can join it. But in case of molting, what is there? You can see here. In case of molting is what? Only you have to after melting the base material, you just keep it. And with time, after it's cooled down, then after it like solidify or will cool down, then it will form, then will join the material. Melting you have understood na. One is plasticity, like use a plasticity man you can like what you can give it another shape. How can you like in the plastic, if you can take a plastic of your bottle, how you simply you can what you can do, whether take your plastic in nearby you, I think nearby yourself you have some plastic material. So whether the plastic material got solidified independently, we have to put some pressure, then we can some distort that plastic material. Is it or not? What about the plastic material inside you? You take your card, you can take your credit card, debit card, you can take your sanitizer bottle, whatever. You have to put pressure to make it deform. But in case of solidify, in case of melting, what is happened? You melt down the what? You melt down some material, and it will after some time because of its cool down, it will call as a cool down. It solidify. Then it will be what? It will be join itself. There is no pressure is required. Okay, so that is the fusion where the metal is melted to make the joint when no pressure is involved. That is called as a fusion welding. Okay, got it? Then we have a resistant welding where both heat and pressure are applied. Then we have pressure welding. This is a pressure welding. Okay, this is a frictional welding is there. This is not a conventional way, but there is a without heat also we can do that. By just simply by pressuring also we can do that. There is a friction kind of this is a newer methodology that friction welding. So for that only pressure welding is required. When the pressure is only applied to a rotating bar where the heat is developed through friction. So heat is there in the form of friction. You should not be put heat to the outside, but there should be heat. That's what I think, the heat term, because you come to know where you will studying that. I think civil department I don't know, but mechanical department you will have thermodynamics class or heat transfer class. So heat, heat is a form of energy. So that thing will become. So here heat is found as a because of the friction. Because if you move the material from one above the another, what will happen? It will create some heat because of the frictional. If you rub your hand also, what will happen? Heat is produced. That itself, that heat is sufficient to make the welding process. So although the this one you can say that this there is no heat, but the heat is there. Heat is heat is there, and it is the internal heat. It is not externally we are supplying heat. Internally heat is produced by the friction. So that is a pressure welding. So fusion welding, resistant welding, and pressure welding, these are the types of welding. So in case of fusion welding, what is there? Arc welding. This is the one category of fusion welding. So then the next one will be the gas welding. So gas welding is the another type of fusion welding. So what is arc welding? We will now see. Okay. So you can see these are the fusion welding processes. So in case of fusion welding processes, we have gas welding processes. So in that case, we have got another T, like these are the example of gas welding processes. One is air acetylene welding, then oxy acetylene welding. These are naming depending on the flame that has been produced during the welding process. So based on the flame produced, we have named it like this. So actually there are three, mostly these trees are these three examples are important for welding process, and there is one more, that is pressure gas welding. But mostly in gas welding, these three are fall into that category. Similarly, we have arc welding process, we have carbon arc welding, then shielded metal arc welding, then submerged arc welding. This is very much innovative process. Submerged are welding, and it has many characteristics. Then gas tungsten arc welding, then gas metal arc welding. So many types of arc welding, so many examples of like how the arc welding process can be done. So different way. There are so many different way we can do this arc welding processes. So you can see here 9, 10 different types of arc welding process you can see here. So you have to remember like few of the, if the example the exam, if you they if you are asked to name some arc welding processes, so you have to remember like carbon arc welding, submerged arc welding, and you have to know something like difference between that. Then we have to know the resistant welding. So resistant welding is where both heat and pressure are applied. So in case of resistant welding, you may have heard of spot welding process. So this is a, and these are more resistant welding processes are there like stream welding, projection welding, resistant butt welding, flash butt welding. Then this is the solid state welding process. So there is the process where like we can come under this category. We have friction welding, force welding, diffusion welding, cold pressure welding. Those are. Then we have thermite welding process. Then radiate energy. These are newer kind of welding processes. Laser welding, electron beam welding, and these are the processes. Like these are the types of welding processes where no like external material has been used to do the joining. But while we have the different like other than welding processes, these are the, we can call it, these are the kind of a joining process which is slightly different from the welding process. So those are the case of soldering, brazing, braze welding, adhesive welding, metal spraying, surfacing, and these are the some of the cutting process. Case cutting, as this is not a welding, this is a cutting process. So this is the gas welding process. So this is a one kind of fusion welding. So you have understood what is fusion welding. So it is fused to make the melt the material by using the heat of combustion of an oxygen or air and the fuel gas. So fuel gas, depending on the fuel gas, we have how many types of we have got. We can get here oxyacetylene or oxyhydrogen or air acetylene. So depending upon the gases and the fuel, we have the name of the gas welding processes. See, a fusion welding process which joins metal using the heat of combustion of an oxygen air and a fuel gas. So if we use air and acetylene, then it will process will be gas welding process will be named as a air acetylene gas welding process. If oxygen and acetylene will be used, then we'll call the oxygen acetylene. If the hydrogen is used, then we'll call the hydrogen oxygen, air hydrogen or oxygen hydrogen welding processes. So what will happen here? Intense heat will be formed to melt the metals. So we're melting the, so what will be the happen? So it has to melting point. It has to the what the temperature should be that much high so that it reaches the melting point of the base material. So the base material is like if you can see tungsten, iron, those iron. Then we have like steel. Those have a very high melting point. So we have to reach that melting point, and so and it has capacity also. Capacity of each welding processes have different value. So it can reach up to 3000 degrees Celsius. Then we'll see here. Then so if you can see here, this is the inner cone. This is because of the this welding torch here, and this is the welding rod has been used, and this is the direction of welding, and this is a base metal and solidified. This is a weld metal, and this is a molten weld metal. Okay, so I'll read it for you. The intense heat flame. This is a flame. So the intense flame does produce melts and fuses together the edges of the parts to be welded, and generally with the addition of a filler material. So normally in case of gas material we have a filler material. So just remember that. So but don't confuse with the brazing or soldering. Brazing and soldering cannot be done with the without the whatever the brazing or this you can call as a filler material. Whatever the material, without that it is not possible. And this gas welding process, this is using that filler material has been used, for carrying out the process. But the ultimately aim is to melting the base material. The ultimate aim is to melting the base material using the heat heat of combustion. Okay. So if the fuel gas is generally employed is acetylene mostly, and however the gases other than acetylene can also be used through with the lower flame temperature. So oxyacetylene, so this you remember, oxyacetylene flame is the most versatile and hottest of all the flame produced by combination of oxygen and other fuel gases. So if the you have to remember this one, like which is the flame has the most hottest flames, which flame has produced the most hotness. So you can say that this is the oxyacetylene flame has been produced the most hottest flame while comparing with the all other combination of oxygen and fuel gases. So it has reached up to a temperature of 3300 degrees Celsius. Okay. Then, in case of acetylene welding, flame is the most important means to control the welding joint. So we have to see the flame. What is the flame is here? We have to see the flame. So correct type of flame is essential for the production of satisfactory welds. So there is different types of flame has been produced by we have to by managing the acetylene welding. If we have to like improvising those things, whatever the manually setting those things, you can get different kind of flames, and depending on the objectives we have to set the flames like that. So the flame must be proper size, shape, condition in order to operate with maximum efficiency. So there are three basic types of oxyacetylene flames. One is neutral welding flame. What is neutral? From the name neutral, you can got the idea that this is the where the acetylene and oxygen in equal proportion. Then we have carburizing welding flame, or it is also named it as a reducing flame. Here we have excess of acetylene. Okay, one is neutral, acetylene, oxygen in equal proportion. Then we have carburizing welding flame. Remember that is the excess of acetylene. When there is excess of acetylene, acetylene is what? Acetylene is the fuel. When there is excess of fuel, which is acetylene here, then we have carburizing flame. And oxidizing flame, from the name oxidizing flame, when the excess of oxygen. So it is very simple. Oxidizing flame, excess of oxygen. Reducing flame, excess of acetylene. And neutral flame, when both are in equal proportion. So depending on that, we can have neutral flame. We have shape kind of this flame is having this kind of shape. So this is the outer envelope, this is the inner core, and this is the tip of the torch. Okay. And similarly, oxidizing flame, outer envelope is less in case of oxidizing flame, and this one has a carburizing flame. Here, additional part is there, feeder. This is a carburizing acetylene feeder you can see here. So additional feeder has been seen in case of carburizing flame. So in the if you have options of having that what kind of flame is that, by looking at the picture you can say that this is a neutral flame, this is an oxidizing flame, and this is a carburizing flame. Okay. And so you can see oxidizing flame has the lower temperature comparatively. You can see here. So I will provide the note for this because it is not like all these things is not possible to complete in one class. So if you can see here, this is the neutral, then carburizing, then oxidizing. How can you recognize the each flame? Like here in the oxygen flame, uh, I think theory copy you can make because actually I don't know the actual how the exam will be going to help. I think there will be some theory classes, maybe theory exams maybe held, because it's a lab class, because this is the introductory to the workshop, because it is because all the branches are there. studying. It is not a mechanical specific. When we have the mechanical specific, then it is required. Actually, when for mechanical student, you should have like taking more interest into the subject, but others should have also taken interest, because this is going to be used while for electrical student, for civil student also you require welding, this kind of like, not only welding, the whatever the workshop manufacturing processes, that will be going to be used somehow in civil engineering, while application of civil engineering. That's why this workshop theory is common to all the branches. So you can make notes, like, it is better, you can keep a notes yourself. So these are gas welding equipments you can have. So this is the common setup of gas welding processes. So this is an oxygen tank, and this is the acetylene tank. So from that we have provide acetylene from oxygen, then it will be put here, then after that this flame is produced. So this is setup of, so if you can see, so all the connections have been there from the both the cylinder, acetylene as well as oxygen cylinder. So these are thoughts. I think in the practical, because it is not a theoretical subject, so in the practically you can get to know when you come to the campus, you go to the workshop, whether you maybe you are not able to come this time, whether what this subjects in going, this course is going on, but when you coming to the campus, you go and see how the welding process is done. It is, you will have interest also, you'll get also interest from that, because it is a very interesting. So you'll get, so many precaution you have to take while having these gas welding processes. So we have to put goggles, gloves, these things are sealed, we have to use. So there is so safety recommendation for gas welding process, it has been there. So these are the, then we have come to know of the arc welding process. So we have to know gas welding process, where we have used gases, air or oxygen or enough fuel, and combination of that we can get, combination of that, if there is some excess, then we can have different kind of flame. If the oxygen is having excess, then we get the oxidizing flame. If the acetylene is excess, then we got the carburizing flame, and both are in proportion, then we'll get the neutral flame. Similarly, we have the arc, not similarly, sorry. Then we have got the other kind of fusion process, fusion welding process, that is arc welding. And in your syllabus only, they are talking about the fusion processes. They are not talking about the those plastic welding processes, pressure welding processes. They are not talking about. One is fusion, one is plastic welding. So these are the main categories of welding process. So just I have asked the question. That's why it is I have asked that question, whether, because plasticity and malleability of the material. One is malleability and one is plasticity. So depending on that, we have got two, actually two main categories of welding. Okay, so similarly we have arc welding processes. So these are different types already I have mentioned. So here in case of, we have here it is supplied by the, this is a welding machine, and this welding machine is either connected to the AC, or the AC or transformer, that is supplied by the transformer, or either connected by the generator. Actually, DC machine is likely more safer to use compared to the AC transformer. So depending on that, whatever the requirement, so because the, if you need a fast welding, then you have to use AC transformer. And if you want to be like, power consumption also less in case of AC transformer, but the power consumption is more in case of the AC generator. So depending on your situation, and how much you the and setup, you can make the arc welding process. But this connection have to be, you have to the purpose is to, you have to get electricity either by AC transformer or by DC generator. Either by AC or the DC you get current, AC current or DC current. That is the purpose. So that will be, then this electricity then flow to the electric holder. One one connection is goes to the electric holder. electrode holder. Then other connection is goes to the working, that is for earthing purposes. So then electrode holder, it contains the electrode. Okay, so I'll read for the process in is electric arc between the electrode and a workpiece or between the two electrodes is utilized to weld base materials is called a arc welding processes. Okay, the basic principle of arc welding is shown in figure. However, the involved arc welding process, some sealing gases where we have to see. So like this, you have to do the arc welding process. You have to put the seal on, and this is the electrode. This is the electrode holder, and this is the electrode. And by flowing through the electricity, you have to join the material, and you have to join the material. How? By melting the material. So this is a fusion welding. These are types of fusion welding. So these are the arc welding equipment. So there you need some power source. Okay. So the available power source either AC or DC. So types of electrodes you can use. Okay, meeting is about to close. Okay, I will closing it. I'll just go for that. I will go to the pressing one. Okay, I will take a snapshot who is present. Then I will go to the pressing one. One second. I don't call your name because it will take more time. I will just I will go. I will just complete it within a minute. Just tell me how much? 11:26. So okay, I will complete in 11:28. So this is brazing. So brazing is a process of joining materials in is during or after heating. The molten filler material is drawn by capillary action into the space between closely adjacent surfaces of the part being joined. Those are the molten filler material. Whatever the filler material has been used, that has been used to join the material. And what is the difference? Main difference is that it doesn't melt the base material which is needed to join. So it temperature is less. So melting point of the filler material is above 450 degrees Celsius, but it's always below the melting temperature of the metals being joined. Okay, so it can be used to join any combination of similar or dissimilar metal, and in the result it produces high strength, but it is not that much high compared to the welding process. It has, depending on the how we have done the welding, that is also main issue, but normally welding process have much higher strength. Welding puts more higher strength compared to the brazing or soldering, but you can have efficient amount of sufficient amount of strength you can have, and with ease you can provide the joining. So these are the some of the brazing alloys that has been used to join the materials, either ferrous material or non-ferrous material. So depending on that we have used. So you can use, and this is the solders also. These are the soldering material. In case of soldering material, we have this, but we do not require. So brazing materials, wide variety forms, including rod, strip, wire, foil. The choice of brazing alloy depend upon the material being joined. So depend upon the material being joined, we have to choose the brazing alloy. So brazing brushes is widely used at a hand torch setting, and the common composition of brazing alloy shown is this. Brazing alloys is shown in this table. So this is a brazing brush. You can see copper, zinc. So these are the melting range, solidifying and liquidifying range. Similarly, we have silver brazing alloys, then aluminum brazing alloys. Okay. Okay. I will stop here. I will just take the name. Okay. Any doubts? You can just ask me. Any doubts? Stop here.